No, like I don't believe it.
Oh, that, I mean, I saw it in the forecast.
Yeah, but what do they know?
More than me, so I'm not entirely sure.
All right, you guys ready?
I'm sure.
So, when we're looking at this one right here, okay, when we're looking at this one right here, let's examine it real fast. So, the picture looks like it's got a spring, okay, and on the spring there's a block, and the spring is currently compressed. There's a little block, and then sometime later, it has shot the block, and the block is moving upward and up. Okay. Fantastic. So, let's do the LOL for this one.
Cool.
All right, so this is the initial, this is the final, this is the energy flow diagram. We're going to write the system in here. This is gravitational, kinetic, and elastic. This is gravitational, this is kinetic, this is elastic. Fantastic. All right, so
That rhymed.
tell me, what's in the system?
Elastic energy.
So we don't put energy in there, right? We put the places where the energy is stored, okay, or how we notice it. Go ahead.
In the park? I mean, the block.
The
Oh,
block.
bring that first.
What?
Bring that first.
Yes, the motion of the block is an energy representation. Good, give me another.
The spring.
The spring.
Jinx.
Fantastic. What else?
I think that's it, Mr. Petty.
There's probably one more. So let's do the energies and we'll come back and finish the system here in a second. All right, so give me the energies. Where's the energy when we start?
Elastic.
Is it all elastic?
I think so.
Well, I've got some gravitational field, doesn't it?
It depends on where you put your zero height, right? So we can put our zero height at the block, at the bottom of the block, or we can put it at the ground. Both these ways are acceptable and valid. I don't care. You tell me which one you want to do. Go ahead.
Can we put the 0 line at the top of the compressed spring?
Sure. So because the block is at the zero height here, there's no gravitational energy in our first picture. Fantastic. So where's the energy then?
Elastic.
It's all in the spring, right?
Yeah.
Okay. How much?
I'd do 4, maybe.
I like 4 blocks. Perfect. All right, what else? Oh, that's it, right? Nothing else?
Yeah, that's all it.
All right, what about over here?
2. Oh, sorry.
Go ahead.
I'll let her raise her hand in a second.
She just speak out loud, son. Speak out loud.
Okay. 2 kinetic energy blocks. Then I'd do probably 1 in gravitational.
Just one?
Oh wait. Maybe, probably 2, I was gonna say.
So, I mean, if we're going to ignore any kind of air resistance because it doesn't mention it, right? So, I actually am okay with this, except for I'm having a little bit of a problem because this elastic energy is stored in the spring. That's part of my system.
Yeah.
This block, the movement of the block represents the kinetic energy. The kinetic energy is represented here, and the block is in the system. But tell me about the gravitational energy. Where is that stored? Where are we going to put that in the system?
The spring is expanding.
So the spring can only store elastic energy. I want to know, where is this gravitational energy stored?
In the block.
Well, it's not in the block because the block hasn't changed at all. You know, kids say, well, it's in the height. but the height is a measurement, it's not an actual thing, right? So we talked about this a little bit yesterday, I'll review again today.
Oh, I know what it
So remember, we talked about this yesterday. This is the gravitational field strength. Remember that?
Yep, I do.
And the gravitational field strength tells you how strong the gravitational field is near the surface of the Earth. And the field does two things for us. All right, the field provides the force, and two, it stores the energy. So when I look over here, what do I have to include in my system then? You have to include the gravitational field. Now, I'm going to show you why we call this the energy flow diagram. Because what ends up happening here is inside the system, there's some energy exchange between our energy storage mechanisms, right? For example, one of the things that happens here is all of the energy is stored in the spring, correct? And once that energy is stored in the spring, it gets converted to the motion of the block. And then as the block goes up, that energy then gets converted to the gravitational field. So we could work inside the system and say like, oh, what's happening? In fact, we know that you start with 4 blocks of energy from the spring. 4 blocks go into the motion of the block, and then as it goes up, 2 of those blocks go into the gravitational field. That's why we call it an energy flow diagram, because inside the system we can show you how the energy is moving. In this case, we included all of our energy storage mechanisms inside the system. So all of the energy is moved within and out of, or within the system. None of it is moved outside the system. Yeah.
So will it always have a difference in height, like to represent like the G field?
Yep. Anytime you get a difference in height, whether it's straight up or down a hill, you know that that's gravitational energy, and that gravitational energy is stored in the gravitational field. All right, so this is an important idea. Did the spring transfer energy to the motion of the block? Did the spring transfer energy to the motion of the block? The answer is yeah. Because if you think about it here, when we started, the block wasn't moving, then it was moving. Where did it get that energy from? It got it from the spring. So, how did it do it? It did it by applying a force. So, the transfer of energy by a force. We call that work. Okay? This is a technical physics term here. Okay? So anytime there's a transfer of energy that happens because of a force, we say that work was done. So in this case, we say work was done by the spring because it transferred the energy. In yesterday's example, when I push this cart, am I transferring energy? Yes, I am.
Yes.
I'm transferring energy into the motion of the cart by a force, so therefore I would say I did work on the cart. Is that cool?
Yeah.
We'll see another example here, but I'll mention it right now. I'm going to drop this ball. As it's falling, does it speed up?
Yes.
Right? And so we know something is applying a force on it. There's energy transfer. It's going from the gravitational field into the motion of the ball. What's applying the force? The gravitational field. So we say the gravitational field is doing work on the ball. Is that cool? Similarly, if I throw it upward, the Earth is pulling it down, the gravitational field is providing a downforce, but it's going up. You're actually getting energy going into the gravitational field. So we still say the gravitational field is doing work. It's just changing the energy in the opposite direction. And we'll see this more. All right. How's that one look? Good? All right, let's do another one. All right, let's look at the next one down. That's an easy one, easy one. Sweeter cart, it's moving fast, it goes up a hill, it slows. Okay? But it's still moving when it gets to the top of the hill. That's like this. If we look at this here, all right, I'm going to get my car moving. So it's moving fast here, it slows down, and it's moving a little bit slower here. This one, sped up on the other. All right? Is that cool? All right, let's do the LOL. Or the bar charts. Oh, Parker's running out of juice. What do you think? All right, here's my initial. Here's my final. This is the four-step. No, the flow diagram. This is the system. This is gravitational, kinetic, elastic. Gravitational, kinetic, elastic. All right. All right, do this one up real fast. All right, how we do? Draw the bars, draw the bars, draw the bars. Draw the bars, draw the bars, draw the bars. Don't wait for me. I'm not helping. I don't want this to be a spectator sport. So there's gonna be some thermal energy loss this time. Because this is a real car.
Yeah.
All right, so what's in the system? Yeah, go ahead.
Cart.
Just talk out loud.
R and the G
Anything else? All right, what do we start with?
4 bars of kinetic.
Okay. What do we end with? 3 kinetics?
Oh.
Yeah, one thermal.
I said something different.
Me too.
I said 1 bar kinetic, 2 gravitational. And then
Did it go up a hill?
It did go up a hill.
So if you go up a hill, you gotta gain some gravitational energy, right?
I said 2 gravitational. 1 kinetic. And then I did 1 thermal out of system.
Yeah, and we're losing some energy because it's a real car rolling, right? Like this. How's that look?
Looks right to me.
Looks good to me too. I mean, it's just as descriptive as we want it to be. And we talked about last week how the amount of kinetic energy tells you how fast you're going, right? The amount of kinetic energy tells you how fast you're going.
Good job.
Here, you've got a lot of kinetic energy because you're going really fast. Here, you're going slow. Yeah.
Would it have also been right if I did 2 bars of kinetic and 1 of gravitational and 1 of thermal?
Also perfect.
Okay.
Okay? Because the representation is the same. You have less kinetic than you started with. Where did it go? It went into gravitational and thermal. Even if you made this a frictionless cart, right? You would have 1 more of this. You'd still have less kinetic than gravitational because you went up a hill. Do you slow down as you go uphill? Yeah, right? You slow down as you go uphill. How's that look? Good? All right.
I don't think I did. I would have given you one if I had one. It's not one of those days.
What's that?
She needed a hair tie. I don't have any today.
A hair tie? Like a scrunchie?
Something like that.
I'm all out of scrunchies, sorry.
You can make your one. That's true. Straight. Okay, okay. Alright. Check it out. Last week. Thank you. I can too.
All right, so what do we call it in physics class when I put a weight on the end of a string and let it swing back and forth? What do we call this thing?
Pendulum.
So people call it a pendulum. I call it a pendulum because I've never seen a J in that word.
Fair
But I
enough.
mean, you can call it whatever you want, right? But you have a sense of it, true?
Tomato, tomato.
Now, I'm going to release it from a certain height here. Can it ever get back to the height that I released it at?
No.
Are you sure?
I'm sure.
I feel like it can.
I've seen videos where it
He goes like, but I've seen something. I've seen something. So let's diagram it up. Let's draw a quick bar chart for it. All right, and you can explain it to me. Explain me.
More than you do. More than Sam. More than-
Oh, man.
more than you do.
Sorry, I forgot to do something. In this last one, I distracted myself. Okay? You have the cart in the G field, right? Okay. When we start this, all the energy's in the cart, some of it goes into the G field, and some of it left the system completely, true? Right? And so what we saw here was, we started with 4 from the cart, we say 1 went to the G field, 1 went out of the system, which was totally good, which means we had 2 left in the cart. Okay? All that's really good here. Is there a transfer of energy? There is, right? So as the cart rolls up the hill, what is doing work on the cart? Okay? What is doing work on the cart? That is the question. And there are 2 things. Okay? Remember, work is the transfer of energy by a force. So when you want to say, what's doing the work? Name the force. Yeah, so one of the things that's doing work on the cart is the G field. That's this transfer of energy right here. What's the other thing?
Friction.
Be careful, we might actually learn something today. I love it. Absolutely. Okay, that's wonderful. Because we have these 2 transfers of energy, if you can name the object that's applying the force, you can say, what's doing the work? Friction's doing the work, gravitational field is doing the work. Cool? Okay. All right, sorry. I meant to do that before I erased it out.
No, you're all right. I forgive you.
Someone washed my board last night, which seems like it should be a good thing, except for it's not. And I'm really frustrated by it. We'll let it go. Just let it go, Don. Just let it go, Don.
Yeah. Come on, Don.
So we're going to let our pendulum swing from A to B and then back to A, which we're going to call C. So A, B, C. Is that cool? So we're going to start it, and when I release it, so go! And then we're going to stop it when it gets back over here. Is that cool?
Yep.
All right, so.
So, Mr. Bennett,
Yeah.
B wouldn't have a diagram?
No. So that's one of the limitations of the,
The LOL diagrams?
yes. Who's trying to get hold of me? Is it Mrs. Pat?